Hello friends, this is Emil with AP. Today I am starting a new video series where we'll all be learning Python and how it is used for data science and machine learning. We'll start with the very fundamentals and then build our understanding from there on. We'll go on through some code using Jupyter Notebook and everything will be clearly explained. This is going to be a series of videos. I'm thinking that it will be around I will be able to cover everything in around 10 videos, okay? And each video will be around 30 minutes long, okay? So overall, I'm planning to have 30 into 10, 300 minutes worth of quality content when it comes to Python. And what are we going to learn in Python? Everything, right? From the very basic core Python fundamentals. We'll After that we'll learn in detail all the packages and libraries. Let's start. Okay, so the first question, how Python was started? So the brief history, there was a Dutch researcher by the name Guido van Rossum. Year was 1991, and he was working on some project and he thought that there is something which should be in between shell scripts on the one side and C on the other side. So if you are aware about C and shell scripts, you can understand the difference, that what he wanted to create somewhere in between, some language as which should be very easy to understand but should not be as verbose as C. Okay, should not have to write so many lines of code as C. Okay, and it should be very compact like shell script. So that was the initial idea for Guido van Rossum. Okay, and once he developed, slowly this language started picking it up. It was developed in 1991. Okay, but between 2005 to 2012, Google adopted it. Google adopted it as the language for their development framework, okay, which made it very, very popular. So the next question would be, why it is so popular? And especially in DSML work, right? Let's start with the first point. The first point is it's being open source. Before Python, most of the softwares which were being used were proprietary in nature. It developed a very strong community. It developed a very strong community. Now, so any open source project, as you know, will be as strong as the community which it supports. Okay. The third thing is the packages and libraries. So a lot of people came and started developing packages and libraries for Python, and especially to deal with their data science, ML, linear algebra sort of work, right? So more people came and more packages became open sourced for Python, more popular it became. Now the fourth thing is, which is, let me put it at D. So any open source language can become more popular if it is being adopted by tech giants. Okay, so they usually popularize it. If they start using, others also follow suit. So Python was adopted initially by Google, as I said. Then it's being used by Meta. It's being used by Amazon. So everybody has started using it. Okay. Last but not the least, why it became lingua franca of the data science world is because another important reason is this language is interpreted and not compiled. So interpreted language and compiled language. The examples are over here interpreted. If I have to give, I will give Python, Ruby, examples like that. Here it is C, C++, etc. Okay. Then compiled languages are something which scans the whole code. Let's say you have written a piece of code over here. It will scan the entire piece of code, okay, in one go. Okay. What it will do, it will scan the entire code, and then if there are any syntactic error or any error over there, it will throw you at the time of compilation also. But in case of interpreted language, what it will do, you have written a code over here, there are various lines, each line is getting executed separately. Okay, one by one it is getting executed, one by one, by the interpreter. If you have any syntactic error, it will run one first line, second line, third line, fourth line, fifth line has a syntax error. It will throw an error over there, an exception. It will throw an exception and it will stop executing from there. Now you will also hear few other terms that Python is written in C, something like that. And this is just from the historical background. So Python is not technically written in C, it is partially written in C. And the way I see it is that C Python, which we refer, is the interpreter. And this is the base interpreter, very fundamental base interpreter. This interpreter is written in C language, okay, by the original creators. Now Python is a language, C Python is not a language, it's an interpreter. So you have to understand the difference between these two. Okay. Now the other thing why I'm saying that it is partially written in C is, you can see lot of packages, lot of Python packages. And if you have to give you an example, Numpy, which we'll deal in subsequent videos in detail, is written in C. Okay. These packages are written in C. Okay. But they are compiled and they are imported. They are imported within Python programs. Okay. Okay, few more concepts. Let's see. So you will keep hearing something like functions and modules and packages and libraries. Now these are the four terms which you'll keep hearing, and sometimes you will keep hearing them in the interchangeable way, right? People do use it. So what is what? Function is if you have any background with any of the programming language, and it's a reusable piece of code, right? So we have to call some piece of code multiple times. What we do is we create a function. Okay, we create a function, and so that it becomes easier for us to just call that. Okay, pass the parameters, call that. That is the basic understanding of function. Module is nothing but a collection of functions. Module is nothing but a collection of functions. So we have put lot of functions, reusable piece of code, into a .py file, and if we import that, then all my functions get imported, okay, at the runtime. So modules can be imported. The example would be like datetime module, random. It's nothing but a collection of functions. Okay. Now, what is package? Now, your package is nothing but a collection of modules. So when we have lot of modules, what you do is you put them together into a folder. So package will always be like a directory. You can compare. It's not a file. It will be like a directory. Okay. You put lot of files inside it. So let's say you will put module 1, module 2, module 3, and you create something like package 1. Okay. Now package is an aggregation of or collection of various modules. Okay. And it is a directory structure. When it is a directory structure, it is only used for namespace purpose. When I say namespace purpose, that when you have to import or call it, you can always call it. If I have to call a particular module, pack1 dot mod1, and let's say inside that there is a function which is called func1. Okay, dot funct1, right? If you have to import, you have to import it like this. Okay, so when you say import, this particular package, this particular function will get imported. Okay, so it is used for namespace purpose. Now the last thing, what is a library? Okay, before that, what is the example of packages, right? So if you have to see packages like Matplotlib. So when we are aggregating modules, we are just not aggregating modules randomly. We are aggregating modules which are very similar, which solves a particular purpose, right? So Matplotlib, all the visualizations modules will be put together into a package which is called Matplotlib. Okay. Libraries are very similar to packages. Okay. And sometimes they are used interchangeably also. You can see a library, a package, a library, and which is fine, right? Your TensorFlow, right? Something become very big, right? A framework in itself, right? Or PyTorch. These are the frameworks for deep learning, right? Sometimes it becomes very big, so we call it a, okay, it's called a aggregation of packages and libraries. Okay, but essentially this also serves the same purpose of namespace, right? And it's a directory structure. This is what important thing we have to remember. Okay, now currently the version which we are using is Python 3. Okay, Python 2 was the earlier version and it became EOL in year 2020. So now there is no use of learning Python 2. It was there till it was, I think it came in 2008 to 2020. And 2020 onwards, any development which is happening, new development it is happening, it will only happen in Python 3. Okay. So there are various ways. The first way is you can download Python. It's an open source software from python.org. Okay. The second would be you can download it from IPython. Okay, so this is, I will just talk about it. It is an interactive Python. Okay. Now the third and the most preferred way, which I always recommend everyone and you should follow if you're a beginner, okay, is something which is called Anaconda. You should always follow this. Okay. And I'll just talk about that why it is you should follow, because it solves a lot of headaches. And if you're a beginner, then you do not want to deal with dependencies. You do not want to which package is installed, which version is installed, which version of Python I need to install, do I need to upgrade my, this particular code is not working with that version of my library. You do not want to deal with all those things, right? So it solves a lot of problems. And mainly what problem it solves, it is essentially a package manager. It is two things. Anaconda is a package manager, manages the package. And the second thing which is the open source distribution of Python. Distribution of Python. It is both the things. Okay, and it does several other things also. Now, why Anaconda is preferred over Python or IPython, right? I will just talk to it in a minute, right? If you just install Python, you can very well install on Windows or your Mac or Linux systems, and you can work around it. What you will get is a command prompt, right? After that, a command prompt. And then you have to code into .py file. It doesn't come with any of the IDE. You can use a text pad or something and to develop. IPython is more interactive. Okay, it's an interactive Python. It does come with an IDE which is Jupyter Notebook. But again, over here, if you have to do package management, you have to rely on pip. Okay, pip is the official package manager for Python. Okay, but with Anaconda, the benefit over here is that you got everything put together. Okay, everything what you need is in one place. You do not have to work with pip. There is an inbuilt Conda package manager which is very good. Okay, when you install, the other benefit is when you install Anaconda, it comes pre-installed with 250 packages which is pre-installed, and they are related to machine learning, data science, deep learning packages, right? It is all coming pre-installed. And then later, or additionally, if you need, you can install 7,500 plus packages also later. Okay, now the third thing I was talking about is Conda, right? Conda is the package manager for Anaconda. It is an alternative of pip, and it is better than pip in the way that it maintains dependencies in a much better way than pip, right? So Conda is always preferred. The fourth and the concept of virtual environment. Now, what is virtual environment? Suppose you're learning or you're creating a project, right? And this project is using a particular version of Python, a particular version of Numpy library. Okay. Now you do not want to install this version of Python and this version of Numpy on your base install. If you do that, then all your program will start using the same thing. What you can do is you can create some sort of isolated environment. Isolated environment. So with Conda, you can create that isolated environment, and after that you can download the right version of Python, the right version of Numpy, and you log into that particular environment, and after that you execute your project, you develop your project, you execute it, and it will all be isolated from your main or root Python. Okay, we'll just see with an example in just a bit. Okay, so this is more on isolation, right? So the base packages or base Python install will not get disturbed, and suppose you want to delete tomorrow, you can always remove this isolated environment. Okay, so that's the benefit of Anaconda. Okay, those are the main benefits. Okay, now let's go and see all these things in actions. Okay, so the first thing first, if you have to install Anaconda, you have to come to anaconda.com/product/distribution. You can go to their homepage, anaconda.com also over here, and then you select the product Anaconda distribution. Okay, this is what we want. And this is totally free. So it's open source Python platform. It comes with the distribution. It comes with the open source Python distribution, and it comes with your basic IDE. Okay, so you'll get Jupyter and you will get Conda and every good things. Okay, and the download is very straightforward. I'm running it on Mac, so I'm seeing it. If you're running on Windows or Linux, you'll get a different download button over here. You download, you select the libraries. I have already downloaded it. I am not going to download one more time. But over here, you need to download. It's slightly big, so ensure that you have enough space on your disk. Okay. Now, once we have downloaded Anaconda, it does various things. One, it will download the open source distribution of Python. It downloads Jupyter Notebook. It downloads Conda package manager. It also has a very good GUI, which is called Conda Navigator. So let me take you over there to Conda Navigator. This is a Conda Navigator. Okay, once you install, you can see the Conda Navigator. You can open it. Now you see a lot of things which are over there. Now, if in case you want to play around with the R also, you do not need to separately go and fetch that. You can do install over here, right? Notebook comes pre-installed over there. PyCharm is another good IDE. If you want to play around with that, you can do a spider. Like it comes with a lot of things pre-packaged. Okay, so this is the Anaconda Navigator. Once you have got that, now let's go and see that what are the how we can play with or how we can fire up your Python programs and everything. Okay, now if the Python is installed or not, how we'll know on your system? So I'm running it on Mac. This is my prompt, but you can run it on command on Windows. Okay, also. So I'll say Python version, and I'm running a Python version 3912. Okay, and this also tells that okay, my Python is installed. The other way to know is that which Python. So if I'm running it from any Python program from here, it will tell me that which Python I'm using. I'm using the Anaconda distribution Python, which is located in Anaconda 3 bin Python. Okay, now Python is installed. Now Python does come with its own shell, okay, a command shell where you can actually code any Python program just on the command shell, and it is called REPL. What is it called? REPL. Okay, REPL understands for read, eval, print, and loop. So it's like it's the core base Python command shell. Okay, and the way to invoke this is you simply type Python over here, and you see these three arrows, these three greater than symbols. These shows you that you are within the core Python REPL module. Okay, now Python is very simple. We will go into the structures and syntax and everything in detail. But over here, let's say if you have to define something like x is equal to 2, and if I have to say what is x, it will give you 2. If I have to say print x, okay, print s, it is going to print me 2, right? So you can basically run, but as you can see, it is not very good. It's not an IDE. It's not very good to develop the program. The way you exit the REPL is through an exit, and you exited. Okay, now let me create a Python hello world Python program, and I will show you hello.py, and all I'm going to write over here is a print statement, which is hello world, and I'm going to close. Okay, so I close this program, and now I'm going to run this program, Python hello.py, and it printed hello world. So my hello world program is printed. Now this is how you run a Python program, right? Again, going to the REPL, you type Python, you get 3 arrows or greater than symbols. It's you can execute any Python program over here, but it's not super useful. So what is the next best thing? The next best thing over there is something called, which is IPython. Now let me clear. Okay, IPython is interactive Python, and the way you invoke is you type IPython. Okay, when you install Anaconda, IPython also come installed with it. Okay, now this is a little more user friendly and interactive over here, as you can see, right? So it comes with a like line number, indentation, and all those things, and it has all other features also, like tab completion and things like that. We'll see, right? So let me see, x is equal to 2. Okay, now I'm saying print. So if you can see that it is trying to give me some suggestions right from the past, but let me just print this. It is printing 2. Okay, so it is more interactive in nature. Okay, but this is also not like this is command prompt. This is somewhat clumsy to do it in command prompt. So we'll exit it. We'll go and see that what is the next best thing to do on the from the IDE perspective. So the name is Jupyter. Let's fire, and the way you fire Jupyter notebook is this: Jupyter, you write on the shell, okay, Jupyter notebook, and you fire. Okay, when you fire up, it will appear something like this. Okay, you create a new Python notebook over here. Languages, we are using the Python 3, and we are using the especially the IPython kernel, the interactive Python kernel behind the scene. Okay, so if you have to open an old Jupyter notebook, you can make a copy, save as, and things like that, right? These are cells. These are called cells. Now there are two types of cells primarily. One is the code cell, and the other is markdown cell. Now, the beauty of Jupyter comes from that you can put your code, you can put your comments, you can put a detailed interactive guide also on over here, and I will show you in just in a minute. Okay, the way you expand the cell is like this. You cut the cell like this, you move the cell up and down like this. Okay, if you have to run all the cells, all the code cells together, then you run like this. You run one cell at a time. There is a shortcut which is shift enter, you can run. So let me just show you. So my first cell is the markdown cell. Markdown cell is mostly for comment, or you want to input anything. The way it works, and probably I will attach something which will have a cheat sheet of all the Jupyter shortcuts. But if I put a pound or hash sign, it marks it that okay, this is a heading, right? So this is a heading, and a run shift enter, and this becomes my heading over here, right? So this is a markdown cell. What I can do is I can actually, you can paste a picture, you can paste some pseudocode, you can write about the code which is following. These are code cells. The next one is the code cell. Now the code cell, again, the same thing. If we have to put x is equal to I executed that. Now, oh, I deleted that. Okay. Now, if you have to print x over here, you see, this is just like your REPL or your IPython interactive shell, but in a more UI format. Okay, so you can essentially do the same thing over here. And this is how most of the development work nowadays in Python are happening. There are other IDEs, but from the learning perspective, nothing is better than Jupyter. Okay, so set it up, guys, for yourself, your environment. It's very easy, user friendly, and then we can do that. Okay, now let's head back to this is about Jupyter. Okay, um, one of the last thing and the cool feature over here is that this also. Okay, so this is the command group. If you are not sure about that, you wanted to do something, so you can just type it over here. And let's say you want to delete cell and you're not seeing that sure about that. Okay, you just run this delete cell and the cell will be deleted from there. You could have actually cut it over here, paste it over here. All those things are over here, but in case you are not sure, you can make use of this. Okay. Apart from that, one last thing is on the kernel, right? Suppose you ran something which is an infinite loop or something, we want to kill it and all, then you can come over here, right? You can interrupt, you can restart the kernel. When you restart the kernel, it refreshes the fresh. Okay. You can interrupt if you're running into some situation that where the program is not ending or it's not running. If you want to run all, you can run all the cells, then you can run this and it will ask the restart and run all cells. It will restart my kernel and it will restart all the cells. So this just got restarted and it executed now. Okay, I have come back on my Mac terminal, and if you're running on Windows, you can go to Windows terminal command prompt, and then let's see that the package manager conda. So the first thing is you run conda version check, and it can tell you that. Let me just increase the font over here. I think it is way too small. Okay, I hope this is okay. Okay, so conda minus v. Now you can update conda with very simple conda update, and you can give the package name. Since conda itself is a package, let me update this conda itself and show you. Okay, so it is going to check if my conda is latest or not, and then it will go ahead and update it. Okay. Okay, so it is saying that, hey, you don't need to worry, all everything is already good, right? Already installed and latest. Okay. Now let's go and see that how we create a virtual environment. So you have to conda create -n, and you have to name the virtual environment name. I'm going to name it as test123. Let's say this is my virtual environment name. And I'm going to state that which Python version I'm going to use. So let's say I'm going to use Python 3.8. Okay. Now the project which I'm developing will work good with Python 3.8. So I want to create an isolated environment for that. Okay. And I will hit enter. It will just take a minute to load everything. I'll just fast forward this. It may take a minute or so. Okay, at the end you can see that my environment is already created. Now the way to activate it is saying is conda activate. If I have to activate my environment, I have to do conda activate test123, and if I have to deactivate, I have to say conda deactivate 123. Okay. Now let's clear and let me go back to the screen. Okay. Now if you are on a Mac OS system, then what you have to do is you have to type conda activate test123. On Windows, you can just write activate or deactivate. Okay. Now I'm activating my conda. Okay. Now, if you recall my initial, now let me see which Python I'm going to use if I'm using over here, right? And as you can see, I'm using inside Anaconda environments test123 bin Python. So there is a new Python which is installed in this virtual environment over here, and this is what I'm going to use. Now, if I have to see my Python version, you can see it has installed a 3.8 version, right? Okay, so to deactivate my environment, what I will going to write is conda deactivate let me just type the correct spelling, conda deactivate, and it will deactivate. Now let me list my environments, conda environment list. Okay, this will list out. So I had a base, and then I had a Python 3.9 which was earlier present, and I have created just now a Python environment which is test123. Now if I want to remove my test123 environment, let's do conda environment remove -n, and then I have to provide the name of the environment, and this will go ahead and remove my environment. Okay, now let's see my list again. This environment is gone. Now earlier I had these three. Okay, now what I have left is only two, my base and my Python 3.9 package. Okay, environment. Today was a general overview of Python. In the next time, we'll start with the Python fundamentals, core Python, its semantics, its structure, its base data type, and from there onwards, we'll go ahead and in each of the subsequent video, we'll learn about various Python packages for the data science and machine learning world, which is Numpy, Pandas, SciPy, Matplotlib, stats model, SKLearn, and everything will be clearly explained. So hang on in over there and wait for my next video. Till that time, this is Machine Learning with AP, ML with AP signing off. Thank you. Have a good day.